This is an example of a geometric progression. It's called a geometric progression because we can't add the same thing every time to get the next number. Instead, we've got to multiply. And on this particular one, we need to multiply by 2 each time to get the next number in the pattern. 3 is the first term of our geometric progression here, and that's often called a. So the first term, a, equals 3. We call the number that we multiply by each time the common ratio, and in this example, the common ratio is 2. Remember, we had to multiply by 2 to get the next number each time. The common ratio is often called r, so we have that r equals 2. Now I'm going to write the sequence in terms of a and r. So the first term here was just a. To get to the next term, I multiplied by 2, so I multiplied a by r. So the second term is ar. To get to the next term, I multiplied by another 2, so that's another r. So I've got a times r again, and that's r squared. Then to get to the next term, I multiply by another r, so I've got ar cubed, and so on. Now if I want to find the nth term of this, let's have a look what happens. We can see that in each term we've got an a, so in the nth term there's definitely going to be an a. Then in this fourth term here, we've got r to the power of 3. In the third term, we've got r to the power of 2. So the power of r is always 1 less than the term. So in this nth term, it's going to be r to the power of n minus 1. So the nth term of a geometric progression is given by ar to the power of n minus 1, where a is the first term of the progression and r is the common ratio. Here's a typical exam question on geometric progressions. I'm told that the first term is 4 and the common ratio is 5, and I want to write down the first 4 terms of the progression. Now I've got the first one here, that's 4. To find the next one, I multiply by the common ratio, which is 5, so 4 times 5 is 20. Then to get the next one, I multiply by 5 again, that's 100. And to get the fourth one, I multiply by 5 again, and that's 500. So these are the first 4 terms. Now I'm being asked to find the 10th term. I could just keep multiplying by 5, but it's probably faster to use the nth term. Remember, the nth term is ar to the power of n minus 1. Now a is the first term, and I know that's 4. R is the common ratio, I know that's 5. And n is 10, so n minus 1 is 9. Now I can use a calculator to get this answer, and I get 7812500. So this is the 10th term. Here's one for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another one for you to try. Be really careful with part A this time. You need to make sure you read the question carefully. Press pause and have a go. When you're ready, press play. Here are the answers. In this first question, I was told that the first term was 3 and the third term was 12, so I've got a term missing in the middle. I tried multiplying by 2 to see if this would work, and it did work straight away, so the common ratio is 2. If 2 hadn't worked, I'd have tried 3 and then 4 and so on. Here's a slightly different looking question. I'm told the fourth and the fifth terms of a geometric sequence, and I'm being asked to find the first term of the sequence. Now the first thing I want to do is work out the common ratio. Because the fourth term and the fifth term are next to each other in the sequence, to get the common ratio, I can divide the fifth term by the fourth term. I'm going to use a calculator to do this, and I get 6. Now remember, I want the first term of the sequence. I've got the fourth and the fifth. The fourth is 1728, and the fifth is 10368. And remember, we're multiplying by 6 each time. So to get this one here, I can divide this by 6. So using a calculator, 1728 divided by 6 gives me 288. That's the third term. I can divide this by 6 to get the second term, and that gives me 48. And to get this one, I just do 48 divided by 6 again, and that's 8. So the first term of the sequence is 8. Here's one for you to try. Remember, you can use a calculator to help you. Press pause and have a go. When you're ready, press play. Here's the answer. The main difference in this question is that the numbers are going down as the progression goes on. I'm being asked for the common ratio. I still find it in the same way. I'm going to get this term here, that's 448, and divide it by the term before it, that's 1792. I can use a calculator for this, and I get 0.25. So my common ratio is 0.25. Because it's between 0 and 1, that explains why this is going down. I now want to find the fifth term. The fourth one is here, that's 28. So to get the fifth one, I multiply that by 0.25, and that gives me 7. To get the eighth term, I'm going to use my nth term rule. That's AR to the power of n minus 1. Remember, A is the first term, that's 1792. R is the common ratio, that's 0.25. And N is the number of the term I'm looking for, that's 8, so n minus 1 is 7. Typing this into a calculator gives me 0.109375, and this is the eighth term of the progression. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here are the answers.